Hi everyone, this is your math guru. In this video, I'm going to solve the following problems that relate to your quadratic equation, your exponential equation, your algebraic fraction, simultaneous equation, nature of roots, and so on. Please don't forget to click on the like and subscribe button below for more easy to understand math concepts. In the first question, we have solve for the unknown variable in each case. The first question says we have 2x squared minus 3x equals to 8. We have to solve leaving an answer to 2 decimal places. In order to apply the quadratic formula, we first of all need to write it as a standard equation. That is, we have ax squared plus bx plus c equals to 0. Therefore, bringing an 8 to the left hand side, we have 2x squared minus 3x minus 8 equals to 0, whereby we have a to be equal to 2, a b is equal to minus 3, and a c is equal to minus 8. We have a quadratic equation which states that x equals minus b plus or minus the square root of b squared minus 4ac divided by 2a. Therefore, substituting the parameters, we have x equals minus b. Because minus b is negative, I'm going to put that in a bracket as minus 3 plus or minus the square root of b squared, that's minus 3 squared, minus, I'm also going to put that in a bracket, 4 times our a, which is 2, and our c, minus 8. I'm going to extend my root bar, all divided by 2a. If we simplify, we have minus times minus, that's plus 3, plus or minus the square root of minus 3 all squared, that's plus 9. And then we have 4 times 2, 8, 8 times 8, 64, minus times minus, plus 64, all over 2a is 2, so that's 4. Therefore, the value of our x equals, I'm going to split up my plus or minus such that I have x equals 3 plus the square root of 73, all divided by 4. That will give us 2.89, or we have a minus, that's x equals 3 minus the square root of 73, all divided by 4, and that will give us minus 1.39. Remember, the question says you should leave our answers in 2 decimal places. The second part of the question says 12x minus 5 times 3 to the power of x equals to 0. That's 12 to the power of x. To start with, I'm going to break down my 12 into prime factors. I have that as 2 to the power of 2, that's 4, times 3, that will give us 12 to the power of x, minus 5 times 3 to the power of x equals to 0. If I open up the bracket, I have 2 to the power of 2x, 3, that's applying laws of exponent, 3 to the power of x, minus 5 times 3 to the power of x equals to 0. Note that I have 2 terms and 3 to the power of x is common to both sides. So therefore, I'm going to factorize 3 to the power of x. I'm left with 2 to the power of 2x minus 5. That's equal to 0. Therefore, I have 3 to the power of x equals to 0. That's false. That's no solution. Because I have to have a positive number for 3 to the power of x. I can have that as 0. On the other side, I have 2 to the power of 2x minus 5 equals to 0. I have 2 to the power of 2x. I'm going to take minus 5 to the other side. Comes plus 5. Applying a log, I have 2, that's the exponent, 2x is equal to the log of 2, 5. Therefore, the value of my x is equal to 1.16 to 2 decimal places. Let's look at the second question. I have given a plus 1 over a equals to 2. We have to solve for a. If you check, this is over 1 and this is over 1. The LCD, or the lowest common denominator, is a. So I'm going to multiply each term by our lowest common denominator, which is a. So I have a times a plus 1 over a times a equals 2 times a. I'm trying to get rid of the fraction. Therefore, I have a squared plus a in a 1. So I have that as plus 1 equals to 2a. I'm going to change that to a quadratic equation. Moving my 2a to my left-hand side, I have a squared minus 2a plus 1 is equal to 0. And if I factorize, I have that as a minus 1, a minus 1. If I fold that, I will get a squared minus 2a plus 1. So therefore, I have my factors. I have a minus 1 equals to 0. That's twice. Therefore, the value of my a equals to 1. Moving my minus 1 to the right-hand side. For the second part of the question, I have 2x squared minus x plus 1 over 2x squared minus x. That's equals to 2. I'm going to let my a equals 2x squared minus x. I'm doing that because I can see that I have 2x squared minus x common, and therefore to simplify my equation, I'm going to make 2x squared minus x equals to a, such that if I replace that in the equation, I have a plus 1 over a is equal to 2. Note that the expression or the equation I have here is exactly the equation I have in my first part of the question. And if you note, the value of my a is equal to 1 as shown below. So therefore, putting that back in the equation, I have a equals to 1. Remember, my a is equal to 2x squared minus x, and that's equal to 1. If I bring my 1 to the left-hand side, I have 2x squared minus 1, or I start with minus x. I'm going to put my constant at the end. I have minus 1. I'm going to correct that. Minus x minus 1 equals to 0. If I use my quadratic formula to solve that, I have my a to be equal to 2. I have my b equals to minus 1, and I have my c equals to minus 1. So slotting that back into the quadratic formula, I have minus b, that's minus in bracket, minus 1, plus or minus the square root of b squared, that's minus 1 all squared, minus 4 times a times c, that's minus 1, all divided by 2 times a, which is 2. If I simplify that, I'm going to have x equals 1 plus the square root of 9 divided by 4, or 1 minus the square root of 9 divided by 4. The square root of 9 is 3. 3 plus 1, 4. 4 divided by 4, I have x equals to 1, or x equals to, that's minus 1 over 2. Let's look at the next question. I got that from 1 minus, that'll be 1 minus 3 over 4. That's minus 2 over 4, which is minus 1 over 2. Let's look at the remaining part of the question. The next question, I have solved for x and y in the following equations. 2y minus x equals to 6, and I'll take that as my equation 1. And the second equation, 4x squared plus y squared equals to 144. That's my equation 2. Because it's simultaneous equation, I'm going to use the substitution method. I have from equation 1, making x the subject of formula, I have 2y minus x equals to 0. Therefore, my x will be equal to 2y minus 6. I tag that as my equation 3. And because I'm using my substitution method, I'm going to substitute equation 3 into the second equation, that's equation 2. And what I have will be every occurrence of x, I replace it with 2y minus 6. So I have 4 in bracket 2y minus 6 all squared plus my y squared equals to 144. If I expand 2y minus 6 all to the power of 2, I'm going to have 4y squared minus 24y plus 36 plus y squared equals to 144. Taking out the bracket, I have 16y squared minus 96y plus 144 plus y squared. And taking mine 144 to the left hand side, I have minus 144 is equal to 0. 144 plus 144 minus 144, that's 0. And putting my new equation together, I have 16y squared plus y squared. That will give me 17y squared minus 96y equals to 0. And if I factorize, I have y 17y minus 96 equals to 0. Therefore, I have y equals to 0, or 17y minus 96 equals to 0. Therefore, the value of y will be 96 over 17, which is the same as 5.65 to 2 decimal places. Therefore, for each value of y, I'm going to find the corresponding value of x. So, if y equals to 0, using my first equation, I have 2y minus x equals to 6 to multiply by 0, which is the value of y, minus x equals to 6. Therefore, my x will be equal to minus 6. And if y equals to 96 over 17, substitute into equation 1 like I did earlier. I have 2 in bracket 96 over 17 close bracket minus x equals to 6. Therefore, the value of my x will be 90. If you punch that in on your calculator, 90 over 17, which is also equal to 5.29 to 2 decimal places. The next question says, if f of x is equal to the square root of 2x plus 2 in a bracket, multiplying x plus 3, and g of x equals 4x plus 3, for which values of x will f of x be non-real? To have f of x to be non-real, then we have the value under the root, which is your 2x plus 2 multiplying x plus 3. We need that to be less than 0 to make that function non-real. Therefore, we have 2x plus 2 less than 0, or we have x plus 3 less than 0. We have the values of x to be minus 1 and minus 3. We are going to check that on a number line to see the region where that is true. So if I have that this way, I have my minus 1 and minus 3. If you slot in the value of x to be minus 4, what I'm going to do is I'm going to test all the regions any number less than -3, I'm going to test -4 on this side. In the middle, I'm going to test -2. And greater than -1, I'm going to test 0. If you slot that back into your question, let me start with -4. If I put -4 back into my 2x, I'm going to test on the right hand side here. I have 2x plus 2 and x plus 3 less than 0. If the value of my x is -4, I have -4 times 2, that's -8, plus 2, that's -6 on that side. Then I have -4 plus 3, that's -1. If you check, I'm not going to have a value less than 0 because -6 times -1 is +6. So -4 is not going to work. What that means is any value less than -3 will not work for that equation or for that function. If I test a value greater than -3, that's -2. If I put in -2 back into my function, I'm going to have -2 times 2, that's -4 plus 2. I have this as -2. And if I slot in -2 plus 3, that will be +1. Then this function is going to be true because -2 times 1 will give me -2, which is less than 0. So at this point, the value is true. Then if I check a number bigger than -1, for example, I'm going to use 0 to test. 0 times 2, that's 0 plus 2. I have that as +2. For my second bracket, I have 0 plus 3, that's +3. 2 times 3 will give me 6, and that's +6. That is not a number less than 0. So therefore, any number greater than 1 will not work for me. It's not going to be true for that function. So the only true region I have is when my x, the value of my x, is greater than -3 and the value of my x is less than -1. Moving my 16 to my left hand side, I have 2x squared plus 8x plus 6 minus 16, that will give us +10, or -10 rather, equals to 0. If I divide through by 2, I have a common factor of 2. I have x squared plus 4x minus 5 equals to 0. If I factorize, I have my 2 bracket, x plus 5 and x minus 1. Therefore, I have x plus 5 equals to 0, or x minus 1 equals to 0. Therefore, I have x equals -5, or x equals to 1. Thanks for watching. Bye.